Hi everyone, my name's Pete Dack. I'm going to be talking to you about reference standards. Radian Research has been designing and manufacturing reference standards for over 35 years. We are now on our third generation of reference standard, which I'll introduce to you in a moment. Prior to that, we had the RD series, the Ditronic, and before that, the original design was the RM, the Medtronic series. So I'm going to be sharing with you a little bit more about why the RX is different. So here you see a standalone benchtop RX30. The RX series comes in three class accuracies: 0.04, which is the RX30, the RX31, which is 0.02%, and the RX33 is 0.01%. So depending on your application, you will choose the appropriate class accuracy. For applications of reference standards, they are used as a reference for calibrating other devices, or you will find them embedded within the device itself. So for example, the 4000 series actually has an RX or an RD standard built inside that we can intercompare the measurements of that internal standard to the external standard. We do this by using a range of standards compare adapters. Similarly with our site analyzer products, the embedded standard is compared with an external calibrated standard, again using intercomparison connection cables. On the display of the RX reference standard, you see we're able to measure active energy, apparent power, as well as reactive energy, as well as phase angle and frequency. We also display the RMS voltage and current of every channel. The RX3 series is a three-phase device. We also have the RX2 series, so 2X, 2.0, 2.1, and 2.3, similar class accuracies, to accommodate single-phase measurements. The display here is bypassed if you wish to connect an external touchscreen monitor to increase the size of the display for other applications. This benchtop configuration with the rack mount option can be changed to accommodate a system application. Every Radian standard is calibrated, traceable to NIST. Every Radian standard is supplied with a comprehensive calibration report detailing the performance of this product relative to the calibration standards used. An example of this calibration report can be found on our website against each of the products. If you don't see the calibration test points that you require, please contact our sales office. We can give you a separate costing for those additional calibration points. The RX series on the rear of the product, similar to the RD series, has three independent phase inputs: L1, L2, L3. Three current channels from low milliamp inputs to high 200 amp inputs. We have on each channel a voltage channel handling 60 volts to 600 volts. In addition, we have a CT input. This is to be used with our current clamp accessories, and each of these are linearized by the memory contained on each of the clamps that we provide. Here you see a number of BNC ports. The 4 ports here are primarily used as programmable pulse ports. Programmable in the sense that they are programmable output pulsing or can input a pulse. Setting the KE value or KH value or setting the direction of pulse is available to you. We have a pulse pickup port for optics. We have 2 BNCs here for a reference input and reference output. This is to frequency lock a number of Radian standards together. Connection to a computer can be done a number of ways. We have the serial port, which is primarily there to support the legacy command structure of the earlier generation RD reference standards. In addition, we now have an Ethernet port, and the command structure for this product has a new, what we call an SCPI, standard command for programmable instrumentation command language, that you'll find much easier and more comprehensive in terms of command control. We also have a USB port as well as an SD slot for memory allocation. On the far left here we have one more BNC. This is what we call our analog sense. The analog sense is used for transducer type calibrations where we can accept a DC input corresponding to the amount of energy being transduced across your transducers. One fundamental change to our earlier designs, the OGS input. To power this device, we're now accepting 24 volt DC, and the AC-DC adapters are supplied with every product. The measurement algorithms for the RX series are different from the RD series. The RX series now incorporate time domain as well as frequency domain type measurements. This allows us to select the best digital algorithms for the types of measurements that you wish to perform. Whether you're handling pure sine waves or full harmonic content, you may wish to switch between time domain and frequency domain type measurements. So that about wraps it up. If you have further questions or need more information on the specifications of the RX series, please go to our website, and the product pages actually have a downloadable data sheet for each of the products in the range. Thank you.